All right, folks, picking up from where we left off yesterday, you can see that today we're continuing on with sine and cosine graphs, but now we're going to talk about some key vocabulary that you'll need to know for how to graph sine and cosine graphs, and also how those vocabulary words affect the transformation of a sine and cosine graph. So starting off with some basics, and then we will do some practice problems. So the basic form of a sine and cosine curve can be found right there and right there. You'll notice that all these letters have been added. So instead of just saying y equals sine of x or y equals cosine of x, now we see these a, b, and d values. Later on in the week, we will also add a c value, which is called a phase shift. But today, we're going to start off nice and simple. So we're going to walk through each of these vocabulary words, starting with the amplitude. You might have heard of the word amplitude in your science classes when talking about waves, but all an amplitude is the distance from the center to the top of the curve or the bottom of the curve. So if you're thinking about your sine curve, the amplitude is the distance from the center to the top, or from the center to the bottom. Since it's a distance, we're always going to measure it with a positive value. So even if your amplitude appears to be negative in an equation, we always measure it with a positive value. We find it by looking at the absolute value of A. A is the number that is in front of sine or cosine. It's the coefficient of sine or cosine. So it is always positive. Just keep that in mind. And it's just a distance. The amplitude stretches out or smushes the sine or cosine curve. The next vocabulary word we're going to look at is period. The period is the horizontal distance it takes to complete a full cycle. So how long does it take to complete the full sine or cosine curve? So for example, with your basic cosine curve that we saw yesterday, it took us 2 pi radians to complete the full cosine curve. Same with a full sine curve. It took us 2 pi radians to go from start to finish to see that entire sine shape occur. The period does not always have to be 2 pi. It can be transformed in the equation based upon a variable that you see up above. That variable that affects period is b. So to find the period, you take 2 pi and divide it by whatever b is. We'll practice doing that in our practice problems in the future. Next one, the center, is just the vertical shift. That affects the center of the curve. And we've now talked about A, B, and the only variable left over is D. So you look at D. If it's a positive D, that means the graph is shifted up. Versus a minus D means the graph is shifted down. The maximum point is the highest point on the y-axis that the graph is going to hit. So this is just the highest point. And to find it, you'll find the amplitude and then add whatever the vertical shift is to it. So it's the vertical shift plus the amplitude. Remember that amplitude is the absolute value of A. The minimum point is very similar. It is the lowest point. And to find it, you take the vertical shift and subtract the amplitude. Before we move on, I think it would be helpful for you to just take note of which of these variables affects the x-axis versus the y-axis, since we're going to be graphing these. The amplitude is the distance from the center to the top or bottom, so that is obviously going to affect our y-axis. The period affects the how long, the horizontal distance it takes to complete the full cycle. That'll affect your x-axis. The center, it's affected by your vertical shift. Vertical things are affecting your y-axis, and the maximum and the minimum are all on your y-axis as well. So just keep those in mind as we start graphing in a minute. Now to practice these vocabulary words, we're going to take a step back and think about our basic sine curve and then our basic cosine curve that we discovered yesterday, and find all of those vocabulary words that we just talked about. So take a second, and if you recall, you'll remember that the whole sine curve went from 0 to 2 pi, and the main points that we care about are 0, pi over 2, pi, 3 pi over 2, and 2 pi. You'll remember from yesterday that we, when we graphed the sine curve, the sine of 0 was 0. So 0, 0 is a point on the graph. The highest point it got up to was 1. The lowest point it got down to was -1. From 0 at pi over 2, it went up to 1. At pi, it went back to 0. At 3 pi over 2, we got down to -1. And then at 2 pi, it went back to 0. Remember, this is not like a linear, like straight curve. It's a flowing curve, so make sure that it looks kind of like a fun little roller coaster ride here. It is also a periodic function, meaning that this cycle is going to continue forever and ever, so it's not just going to stop at those endpoints. Make sure you're continuing with arrows on each side. The period is how long it takes for us to see that full sine curve from start to finish on the x-axis. In a basic sine curve, it takes 2 pi radian to complete that sine curve. The amplitude is the distance from the center of the curve, distance from the center to the top, or from the center to the bottom. So what do you notice our amplitude is here? Hopefully you're thinking it is an amplitude of 1. You can also see that amplitude of 1 by looking at the coefficient in front of sine. The number in front of sine, while you can't see it, is an assumed 1. The domain we worked on a little bit yesterday. Since it's a periodic function and continues forever and ever to the left and to the right, your domain goes from -infinity to +infinity. Your range does not, however. It is stuck in between those two y values. Remember to put your lowest one on the left, highest one on the right, and it touches those endpoints, so make sure to include brackets. The maximum y value is 1, the minimum y value is -1, and you can see both of those show up in the range. The center value, there's no vertical shift, there's nothing that's been added to sine, so the center is just 0, and we can list our x-intercepts, 0, 0, pi 0, and 2 pi 0. When you're starting your basic sine curve, remember it starts at center value of 0. And I referenced you needing to know this pattern of a sine curve that I'll reference over and over again. A sine curve starts at the center, goes to the top, goes back to the center, down to the bottom, and then back to the center. So keep this little diddly in mind for when we have more transformations later. Let's take a look at cosine. The parent graph of a cosine curve is just y equals cosine of x. Go ahead and label your x-axis from 0 to 2 pi. You'll remember from yesterday the highest point it reached was 1, lowest was -1. Cosine was different than sine in that the cosine of 0 is 1, so it started out really high. At pi over 2, at 90 degrees, it reaches 0. At pi, it goes down to -1, back to 0, and then at 2 pi, it's back to +1. Just like with the sine curve, it's a periodic function, so this U-shaped curve will continue to the left and to the right. So make sure that it's not like shooting up past 1. The 1 is the highest value. Make sure that you're just drawing an arrow to show that this pattern would continue to the left and to the right. Let's talk about the period, how long it takes for this full cosine curve to complete. To see the full U-shaped curve, it took 2 pi radians. The amplitude is the distance from the center to the top, or the center to the bottom. Remember, it's always a positive value. You can also find it by looking in front of, for the coefficient of cosine, and in this case, it is 1. Amplitude of your parent function is just 1. Domain, we spoke about yesterday, just negative infinity to positive infinity. It includes all x values, the range stuck in between -1 and 1, your minimum and maximum and minimum values. The center is 0, and your x-intercepts of your parent function were pi over 2, 0, and 3 pi over 2, 0, where it crosses that x-axis. So, key thing to know about the parent function starts at 1, and the pattern that you need to remember for your cosine curve that I will be referencing over and over again starts at the top, goes to the center at the next ordered pair, goes down to the bottom, comes back to the center, and then back up to the top. Those highlighted patterns will come in handy for you to remember when you're graphing each of your ordered pairs in these next practice graphs. This next page, we're going to sum up the transformations that can occur, starting with amplitude, period, and vertical shift. So remember, the amplitude is just found by looking at the absolute value of A. The period is found by taking 2 pi and dividing by B. That'll affect your x-axis. If you see a vertical shift, you'll find it with the D value, whatever's been added or subtracted to the cosine curve, plus D tells you to shift D units up, minus D tells you to shift D units down. Now I want to rewind a second. This amplitude, whether it's positive or negative, is going to affect your pattern of your sine or cosine curve. If your amplitude out in front here is a positive amplitude, that means that it's going to keep that same basic pattern of a sine curve. So it's going to start at the center, go to the top, back to the center, bottom, and then back to center. If, however, you have a negative out in front, it's going to reflect your whole entire curve over the x-axis, meaning that it affects your pattern. We're still going to start at the center, but instead of going to the top of the sine curve, you're going to go to the bottom, back to the center, up to the top, and then back to the center. It reflects the graph over the x-axis. So it's going to become center, bottom, center, top, center. Again, that occurs when you have a negative amplitude. It flips the curve over the x-axis. Let's go ahead and look at what would happen to cosine. If it was a positive amplitude, it would keep your basic pattern. So think about your basic cosine curve, the U-shaped curve. Starts at the top, center, bottom, center, top. And we're talking about our key points along the way. If, on the other hand, you have a negative amplitude, it's going to reflect the entire curve over the x-axis. So instead of starting at the top, it's now going to bing, flip over and hit the bottom. Then go back to the center, go to the top, center, bottom. So it's now going to look like a little anthill instead of a ditch. So it'll start at the bottom, center, top, center, bottom. Think of it just as a little flip. This occurs, again, if you have a negative amplitude. And we'll see some of that today. Down beneath there on this second page of notes, you'll see some steps for how to graph one cycle of a sine or cosine curve. I'm not going to read those to you because I know you can read, but this is a great thing to come back to if you're ever stumped by something. I do want to point out down at the bottom, if you wanted to graph on the calculator, you can always graph trig functions on the calculator, but check out here. What mode does that say it needs to be in? Yeah, that's right, radian mode. If you keep it in degree mode, it will just show up as a flat line. So make sure you're changing it to radian mode and then to focus on one cycle, push zoom 7. Let's go ahead and try some on the back. All right, let's take a look at this first function. Before we even start graphing on the x or y axis, we are going to figure out all these vocabulary words. We're first going to figure out the amplitude. Remember, the amplitude is the coefficient in front of sine or cosine. So in this case, our amplitude is 3. That means that from the center to the top or from the center to the bottom, we're being vertically stretched by 3. To find the period, we take 2 pi, always 2 pi, and divide by b. b is the coefficient in front of x here. Well, what coefficient do we see there? Just 1. So 2 pi divided by 1, we get a period of 2 pi. That means it's going to take us a horizontal distance of 2 pi to complete this full sine curve. The last thing we're going to look at is the vertical shift. The vertical shift is found at the end. It is the constant that's either added or subtracted to the sine curve. In this case, it is -1. So that means that the whole sine curve is being shifted vertically down 1. The pattern that I want you to write out is the pattern that we practiced on the pages before. Think about your sine curve. Sine curve starts at the center, goes to the top, back to center, down to the bottom, and back to the center again. The only way this would change with the sine curve is if there's a negative out in front. Since there's no negative, we would say it's center, top, center, bottom, center. Let's now go over to our coordinate plane and label our x and y axis with this important information. So first of all, our amplitude and our center. There's been a vertical shift down 1. We know that our new center is going to now occur down 1 from the original x-axis. I would put a dotted line across the graph because when we talk about center, top, center, bottom, center, this is the new center line that graph is coming to. The amplitude is 3, so that means we are going to count 3 units above that center. 1, 2, 3. We can label that 2. And 3 below. 1, 2, 3. So we go down to -4. You can think of that amplitude as a vertical stretch. The next thing we'll label, so that took care of the vertical shift and the amplitude. The next thing we'll label is the period. We're starting at 0. There's been no horizontal shift. We won't add that until later in the week. But we know we're ending at 2 pi. This is just like a normal sine curve that you've seen before. So what's in between 0 and 2 pi? Pi. What's in between 0 and pi? Pi over 2. And what's in between pi and 2 pi? 3 pi over 2. You'll need to label each of those x-axis values. Then, once you've done that, you've labeled your x-axis, you've labeled your y-axis. Now we can put the ordered pairs on the graph. We'll start at the y-axis. Since it's a sine curve, we'll start at the center. Then we'll go to the top. So at our next x-axis tick, we'll go up to the top of the graph, which is our maximum value of 2. At the next tick mark, we'll go back to the center. Next one, we'll go down to the bottom, which is -4. So at 3 pi over 2, we're at -4. And then we'll go back to the center. Notice how when I go back to the center, I'm going back to that vertical shift line, not to the x-axis. Once you have that full cycle, that full pattern complete, you can connect your points, and you've got yourself your lovely sine curve. Last thing we'll find is the domain and range. Let's do that off to the side. Domain is never going to change. It's a periodic function, meaning it continues on forever and ever in this same cycle, so it's negative infinity to positive infinity. The range goes down to our lowest y value of -4 and our highest y value of 2, inclusive, meaning you should have brackets. Let's move on down and try out the cosine curve beneath here. Before we label our x and y axis, let's find all of our key vocabulary words, starting out with the amplitude. Remember, the amplitude is situated out in front. You need to label these A, B, and D. That might be helpful. The amplitude is always positive, so in this case it's 3. To find the period, that affects the x-axis, remember, it's 2 pi divided by your b value, 2. That simplifies. 2 divided by 2 is 1, so now we have a period of pi. What that means is instead of completing a full cycle in 2 pi radians, now it's getting scrunched up, and it only takes pi radians to complete the full cosine curve. The vertical shift is at the end. It is again -1, so that means we're taking our whole graph and shifting down 1, so our new center line will be down 1. And the pattern, well, it's a cosine curve. So think about your basic cosine curve. Starts at the top, goes to the center, down to the bottom, back to the center, and back up to the top. The only time we would flip that if there's a negative out in front, and since there is no negative out in front, we keep that same pattern. Let's go ahead and label our y-axis first. The new center line has been shifted down 1. And we will label that -1. Going along with that, we can use the amplitude up here to go above that center line 3 units. 1, 2, 3. So our max again is at 2. And 1, 2, 3, down to -4. And now let's label our x-axis. We're starting at the y-axis and going all the way to pi. Think about what is in between 0 and pi. What's in between 0 and 1 whole? That would be pi over 2. What is in between 0 and 1/2? 1/4. You would just take 1/2 and divide by 2, we get pi over 4. What's in between 1/2 and 1 whole? 3/4. So we can label that 3 pi over 4. So we've labeled our x-axis, we've labeled our y-axis. Now we're ready to put the graph on the coordinate plane. We'll use our pattern down here to help us out. On the y-axis where we start, we'll go up to our top. Then at pi over 4, we'll go back to our center. Remember, our center has been vertically shifted down. Then we'll go down to the bottom, back to the center, back up to the top. Remember that it is a periodic function, so that graph should continue on either side with arrows. It's not shooting up toward infinity. It's continuing that same kind of roller coaster pattern. Last thing we'll find is the domain and range. Domain is never going to change. Negative infinity to positive infinity. The range, lowest y value to highest y value. Let's take a look at our final cosine curve down here. Our amplitude is the absolute value of the coefficient out in front of cosine, so it is just 2. Don't worry, this negative we will take into account later on. If you want to highlight that, maybe put a star next to it. I always like to draw attention to the fact that there's a negative because it is going to affect your pattern later on. The period affects the x-axis. It is 2 pi divided by b, which in this case is 1/4. So A, B, D. All right, when you're dividing fractions, take 2 pi, you change the division to multiplication, and you flip the denominator. 2 times 4 is 8 pi. If that was confusing, you can always take your calculator and do 2 divided by 1/4. You'll get 8. Just make sure to tack on a pi at the end. So when you divide by a fraction, notice how our period got longer. The vertical shift, you find that by looking at D, and it is +1. So that means we're going up 1 for our new center line. And now the pattern. Normally, a cosine curve starts at the top, but because of that negative sign, it is reflected over the x-axis. So we're actually going to start at the bottom, then go to the center, then the top, then the center, and then back to the bottom. So it flips it on its head. That is all because of that negative out in front. Let's go ahead and label the y-axis first. The vertical shift is up 1. So take your whole center line, shift it up 1. Next thing we'll take into account is the amplitude. The amplitude goes 2 above it and 2 below. So we have 3 and 2 below, -1. Now let's label our x-axis. We're starting at 0 and going all the way to 8 pi. You'll always need a total of 5 tick marks. The way you can remember that is for each piece of the pattern. Remember that when there's no phase shift, there's no horizontal shift, which we won't have today, it always is going to start on the y-axis. That will not always be the case, but in these problems where there's no phase shift, it is. So we have 1, 2, 3, 4, 5. Think about what's in between 0 and 8 pi. That's 4 pi. What's in between 0 and 4 pi? That's 2 pi. What's in between 4 and 8? That would be 6 pi. So we've got our x and y axis labeled. Now we can put our ordered pairs on the graph. We're going to go down to the bottom, start there. Go to our next tick mark, go to the center. Our next tick mark, we go to the top. Next tick mark, back to the center. And last tick mark, we go back to the bottom. Final step, we'll talk about the domain and the range. Domain never changes, it continues on forever. The range, the lowest y value is -1, the highest is 3. Make sure you have brackets on the end of those. So we've looked through 3 examples of graphing some basic transformed sine and cosine curves. Rewind and re-listen to any of those if they were confusing. Otherwise, give your homework a shot.